Hi, good morning, good afternoon, or good night. In this video, we will learn how to derive halftime equations. But first, let's remember the definition of halftime. Halftime, or T1/2, it's the time required for the concentration of a reactant to decrease to half of its initial concentration. Having said that, we can start deriving our halftime equations. So right here we have this table that will help us remembering our concentration time equations for our different orders. We also have the half-life equations, which are the ones that we're trying to figure out. So let's start with the zero order half-life. So right here we have the concentration time equation for a zero order reaction, and since we're looking for T1/2, the first thing we want to do is solve for T. So as you may recall, we have the current concentration, which is on our left side, and then we have K, which is our reaction constant, and then we have T, which is our time, and plus initial concentration. So let's go ahead and move the initial concentration towards the left side. So we would have current concentration minus initial concentration would equal to negative K times T. Okay, we're almost done. Well, solving for T. Then we have T. Okay, so K is multiplying T, so we would our K will be dividing these things right here. So we would have current concentration minus initial concentration over negative K. So don't forget the signs, okay guys? So, okay, now we already solved for T, but we're looking for T1/2. Okay, so by definition of half-life, it's when T equals 1/2 and the current concentration, it's equal to initial concentration over 2. So let's go ahead and start modifying this equation we just got. So we would have T1/2 equals initial concentration over 2. So is these, it's going to be this. Then minus initial concentration over negative K. So as you can see, we already have the formula for T1/2, but it's a little bit messy. So let's try to rearrange this equation. Okay, so before we move on, I would like you to show you a cool trick. So I don't know if you know this, but I call it the tortilla rule. So it's whenever you have one fraction over another fraction, when you're dividing one fraction by another. So you want to multiply the ones outside, and these ones will be your numerator. So A times D will be your numerator, and B times C will be your denominator. Okay, so this is a cool trick for you guys to use. So let's say we have, so just a quick example. So 4 over 2 divided by 1/2. So we already know the answer for this one, right? Let's see. I'm using like easy numbers so you can know it actually works. So we know 4 over 2 is 2 divided 1 by 1/2. It's going to give you 4, right? So let's see if this tortilla rule works. So you will multiply the ones that are on the outside. So 4 times 2 over 2 times 1. Okay, so we can eliminate the 2, cross it out, and we got 4. So yeah, it actually works. Okay, so that was a cool trick. So let's move on to our equation. So right here, we want to put rearrange this numerator because it's a little bit weird and messy. So let's try to simplify it. So we would have t1/2 so actually we have like a 1 right here. It's there, but we don't like write it. So we would have negative. Yeah, okay, so be aware of the signs. Over 2. This fraction over negative k. Okay, so here we can actually apply the tortilla rule. So as I said earlier, usually all numbers have a 1 on the bottom, so denominator. So we can just go ahead and put a 1 right here. So we're going to apply the tortilla rule. So we have the ones, we're multiplying the ones outside. And this. So let's go. So t1/2, let me get another color. So t1/2 would be negative initial concentration, because the ones that are on the outside are going to be our numerator, over 2 times negative k, so 2k. And then we have negative signs, so we can go ahead and cross them out, cancel them out. So then our resultant t1/2 for the zero order reaction, it's going to be initial concentration over 2k. And let's see if this is true. If it's true, let's go to the table. Yeah, there we go. Now you know how we got the half-life equation. So this is a half-life equation for the zero order reaction. So as you can see, the t1/2 formula for a zero order reaction suggests that the half-life depends on the amount of initial concentration and rate constant. Yeah, so here we have the initial concentration and the rate constant. A fun fact is that many of the known zero order reactions take place on a metal surface. If you like this kind of videos, I recommend you seeing part 2 and part 3 since we're covering the other half-life equations. I would also highly suggest you to subscribe to Hydrogen Bonds Are Fun and to follow us on our Instagram page. Thank you.